You're gonna get strangled. Okay. Welcome to the. I was talking to a cat. I'm sorry. Um, welcome to Unit 7 Quiz Review Video Edition. We're gonna try to take you through the stuff that you need to know, practice if you're not in class when we do the review and the quiz. So without further ado. Here are some details on the Unit 7 quiz. So the quiz is going to be done on formative. We've done a lot of the lessons in this like kind of mini unit on formative, and so the quiz is going to be there as well. You will have access to Desmos, but not other websites, and in fact, you're expected to use and will be required to use Desmos and demonstrate that you're using it on the questions, but you will be locked down so that you cannot get to other websites. Only one of the problems will require you to factor by hand. Okay, so if you feel like that is a weak spot where you're carrying out and executing all the factoring, just kind of keep in mind there's only one problem that's going to require you to do that. You might want to save that one to last, especially if it's going to make you a little nervous. For most problems requiring work, you will be asked to paste a screenshot of your Desmos graph, and you will not receive full credit if you do not paste the graph when directed to do so. So just if it says paste the graph in the spot below, you do need to make sure that you're doing that. Read the directions carefully. Don't just choose the correct answer and move on to the next one. If it's a multiple choice question and you're asked to submit the graph also, like that's going to be part of the point value. You will be timed using the average time of 2.5 minutes per problem. I did round up, so you have a little bit more than 2.5 minutes per problem to do it. If you are a student with an extended time accommodation on an IEP or a 504, then you will have a longer window, but we'll need to reset it at the end of the class if needed. And I also included ESOL students in that as an accommodation for language. And just the last thing, there was clear evidence that some students accessed AI or some kind of application like Photomath or Mathway. I know there's several of them out there on the Unit 6 test. If I even see a phone, okay, on your lap, if it's poking out from under your leg because you're sitting on it, if you've got it hiding behind a bag or something, if you're hiding it behind the laptop itself and I'm walking around and I see you, grab or move a phone, you will receive a 0 on this assessment with no option to make it up. And the reason I have to crack down on that is because it was very plain that some people were using some kind of AI on the other tests. I didn't catch you doing it, but I know now that I need to keep a closer eye out for that. So don't play that game. Make sure you know how to use. You're allowed to use Desmos, so make sure that you are not doing anything you should not be doing. Okay. All right. So what do you need to know? Be able to answer a multiple choice question on simplifying rational expressions or operating on rational expressions. Sorry for the typo there. By matching graphs. So this one is an operation, but you could also use this technique. Really, this is the cat that I was speaking to when I started recording. He's just not very disciplined. I tell him to move and he doesn't listen to me. Okay, so it could be used for either type. And notice it says your Desmos graph must show both the original expression and the answer choice in the equations block. If you're not sure of when, I'll show you what I mean by that. So let's turn on the graphing calculator. So if you are doing this using Desmos, and you're welcome to also do it by hand, but remember that you are on a time limit. So we would type in the original expression, which is 3 over x plus 2 plus 5 over x minus 2, and we get that graph. And now we're going to type in our answer choices. So I have 8 over 2x. That is clearly not the right answer choice because the graphs don't match up. So I'm not going to pick 8 or A. The next one is 8 over. Now, remember this. Don't click the X to delete that entire equation, okay? That wastes a lot of time if you're deleting all the equations and you're typing all of them from scratch to match them up. So for the next one, I still need the 8, I still need the X, and then I'm going to have a minus 1. That does not match up, and so we're not picking B. The next one is 4 over x. Okay, also does not match up. Now at this point, you might feel comfortable, like just go right ahead and pick answer choice D, but if you have the time, D would be 8x plus 4 over x squared minus 4, and that does match up. Now, when I'm talking about making sure you screenshot the whole thing, this is what I mean by that. Your screenshot needs to show me what you've graphed as well as just the graph. If you only screenshot the graph, I don't know if you only graphed the problem or if you graphed the problem and the solution, because notice that the red graph is now completely hidden underneath the blue graph, and I need to be able to see that. On the formative that covered this, a lot of students only showed the graph of one thing, and you lost some points on that question because you weren't using Desmos to answer the question. You were going with what I showed you the answer was, and then we're not screenshotting everything. So for these problems, you do need to show both the equations and the graph. If you want to screenshot the entire screen, that's fine. If you want to snip it, that is also fine. Just make sure that you're snipping the equations with the graph. Now, solving the equations does not require that because you're going to have two different graphs and I'll be able to see them. But if you're just not sure, like that you're going to remember it, just always screenshot the equation with the graph, okay? And you can't go wrong with that. So we would pick answer choice D, and this strategy would work for any equation expression that you were asked to simplify, and it also works for operating. So if you see a plus sign, a minus sign, and so forth. Okay, I kicked myself off this slide. Okay, so the next type is be able to solve rational equations. So take a look at that. That looks very similar to the one that you just saw, except instead of a plus sign, there is an equal sign, which is what is critical for being an equation. Equations have equal signs, and both the last kind and this kind can be done with Desmos. But when you're simplifying or operating, what you're looking for are graphs that match up with each other. When you're solving an equation, you are graphing them and looking for the points of intersection. And that's why sometimes I get on different people's cases when we just say, well, I'd use Desmos. Well, okay, but there's lots of things you could use Desmos to do in terms of like graphing and what are you looking for when you're using it, or maybe you're just using it to do a calculation. So we want to be really clear about what we're looking for. So for this one, what our strategy would be is to graph the left side, and I do strongly encourage you to graph it as y equals. That just enables the behavior with the intersections for some types of equations in ways that aren't if you just graph it as an expression. And then we have y equals 5 over x minus 2, and we are looking for the point or points of intersection. I cannot zoom in and out really well on this. Okay, I can do it a little bit. And it's possible, we talked about this in class, that you have a stealth point of intersection that's somewhere way, 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 way far away. These graphs do intersect, but right here I can see very clearly that it does cross at x equals -8, which means that it's either A or B. And then I can eliminate B because when I'm looking at x equals 0, I can see that they clearly don't intersect there, or that they probably don't. And you could reason that out looking at your asymptotes, okay, and figure like, no, they don't actually cross there. Actually, it would make them not a function because you can see the y-intercept for the blue function is right there, and the y-intercept for the red function is right there, and they're not at the same place. And we know that it can't have more than one y-intercept, so it can't have two y-intercepts. So we can see both of them. So that would eliminate B, and so our answer choice would be A. And once again, on your test, you are going to be required to snip your Desmos graph. You don't need to snip it with the equations on these ones, but you can go right ahead and do that, especially if you feel like, oh my word, I'm going to forget. Just always snip the equations with them. So that covers actually several of the problems on your quiz are going to be doable on Desmos just like that, and you just snip the graph as your work. Oh, that's right. I messed up this slide. All right. Okay, next one, be able to match a reciprocal graph with its function. This is a multiple choice question. Desmos can be used to do it, but it is faster by hand, so I would not recommend you do this. So you would be given like a function like this, and you're welcome to go and graph it on Desmos and then go back to your answer choices and see which one of those graphs matches the one that you generated. But I honestly think it's faster to do it this way. We know that this function is going to go right 4 and down 2. And so basically you would look at your answer choices and you're going to look for something that goes right 4 and down 2. And it would look something like that. And that probably took me less time than it would to graph on Desmos. But you're looking at right 4 down 2, go through your answer choices, look for the ones that have the asymptotes at right 4 down 2. So that will be a multiple choice question. All right, now that I've finally navigated my way out of the flub I did 2 slides ago, and I know you guys can't tell, but when I do that, I advance and I can't go backwards, and I have to go back, and then I have to stop, and every slide is actually a separate recording instead of just being able to click through the slides. But all right, so next one, be able to identify vertical and horizontal asymptotes of reciprocal functions as well as domain and range. And so these, I believe, are also multiple choice. So it says a reciprocal function is translated 3 units left and 2 units up. What is the equation of the vertical asymptote? And then what is the range? You can do this any number of ways, but for us in these purposes, we'll just say to make something go 3 units left, we would add 3 in the denominator, and 2 units up means it would go up 2. And so now, do I know whether it is flipped or stretched? We didn't really say. I'm going to assume no. If they wanted a flip or a stretch, we would have said so. And so that should work. 3 units left and up 2. And so we're going to go 3 units left and up 2. And there's our graph, would be right here. Okay, so what is the equation of the vertical asymptote? Remember, vertical asymptotes always take the form x equals, and this would be at x equals -3. You can also reason that out looking over here at the function. When x is equal to -3, that's when you're going to have a 0 in the denominator. So that's how you know that there's an asymptote there. And then you might be asked something like, what is the range? And you could do that by looking at this, like it goes up until you get to the 2 and then continues on. So you have that asymptote there. So it could be something like y does not equal 2, or it could be like -infinity to 2 and then 2 to infinity. Either one of those notations is fair game. And there are a couple of multiple choice questions along those lines. You're also welcome to process of elimination this other ways. So if you see something that is asking you for a vertical asymptote and it says y equals, then you know that that isn't it. You could also graph the answer choices. So you could graph like y equals -3, y equals 3, y equals 2, x equals -3, whatever your answer choices are, and then see if those match the requirements of something that has been shifted, in this case 3 units left and 2 units up. So several different ways that you could approach that. Right, be able to identify all the transformations on a reciprocal function. So identify all the transformations on this. So we've got, what do we have? We have the 2 is a vertical stretch. We have right 1 and up 4. And there, this could be combined with something like what are the asymptotes, or what is the domain and range. So a multiple select question that just says select all that would apply to this. I could say it goes up 4, but it has a vertical asymptote at x equals 1, and the domain is everything but 1. So there's a lot of ways we could do that, and you would just have to know all of the things that pertain to that. You could graph it on Desmos and then go through the answer choices from there. Okay, so those are some of the options for answering that particular kind of question. Now, I think this is an interesting one. We didn't spend a lot of time talking about this, but it is something that you might see. So know how to determine if there is a hole or an asymptote if the function does not exist at a given point. And so we know that rational functions have these breaks in them, and we've seen that with a lot of the graphs. You got something going on over here, and then a break, and then something going on, and then a break, and then something going on. So how do you determine what exactly is going on? Well, first, you do need to factor everything. And that denominator, just to do a quick review of the factoring, we have x squared, we have a -3. We're looking for 2 numbers that multiply to -3 that add up to -2, which would be -3 and +1. And so we would have x minus 3 and x plus 1. Okay, and then this one I wrote so that it was actually the same. So x minus 3 and x plus 1. And here's the deal. This function does not exist. Okay, so we're going to say does not exist when x is equal to 3, because 3 minus 3 would give you zeros, a 0 in the denominator, and it also does not exist at x equals -1, because -1 plus 1 will give you a 0 in the denominator, which means you can't have a function there. And this is the same way. Okay, so does not exist. Okay, now how do you know if it's an asymptote or a hole? If none of your factors are like match up, so you don't have a factor, the same factor in the numerator and denominator. So because this does not have an x minus 3 in the numerator, and it does not have an x plus 1 in the numerator, these are both asymptotes. And if you wanted to go graph it, okay, you could. But see how this one has the same factor? What that means is that this one is an asymptote, but this one is a hole. So when you see the factors canceling out, the function still does not exist there, but it's actually a hole. And sometimes when we're graphing it, we'll just put like a little open circle, like there's a hole in the graph. Desmos won't show it to you. So Desmos, it will actually look like a solid line because you can't see when one point is removed. And so it'll look like a solid line. You won't see the hole. You could also answer this question by hopping over to Desmos and graphing it and then seeing what you've got going on. You could also like type in a particular value for x and see if like the denominator is not factored. You could type in like x equals 3 or x equals 1 and see what's going to happen there. Okay, so holes versus asymptotes. And this is the last one. Be able to simplify and or operate on rational functions by hand, or identify errors in procedure if you're shown sample work. So I've got a multiplication one there. There is only one problem where you are going to have to do out all the factoring and show your work. If you really want to, I can give you a piece of paper and you can do it on a separate piece of paper and just hand in your paper to me instead of doing the work on formative. I think that's acceptable for this purpose. So here we have multiplying. and we need to do like a bunch of factoring. So I'm going to set up my factoring. This is actually the same one we just did. So, and that's something to note too. There's only so many factoring problems that teachers can give you before we start running out of them. So we already established that this was negative 3x and 1x. And so we get negative x minus 3 and x plus 1. And then we factor the next one, which is x squared. And then we have a minus 6. And we need two factors of negative 6 that add up to negative 1. That is negative 3x and 2x. So we have negative 3 and positive 2. And then we have this one, and this has got the 2x squared and the 6. And we do have to do 2 times 6 is 12. We're looking for two factors of 12 that add up to 7, and those would be 4 and 3. GCF between 2x squared and 4x is 2x, and that means that must be just the x. This must be a 2, and this must be a 3. And so we have x plus 2 and 2x plus 3. And then last but not least, we have a difference of squares. So that'll be x plus 1 and x minus 1. Okay, and then this is multiplication. You can cancel any numerator with any denominator, but you may not cancel side to side. Okay, no side to side canceling. It's always a numerator with a denominator. So we can cancel x minus 3 with x minus 3. I can cancel an x plus 1 with an x plus 1 in the denominator. I can cancel an x plus 2 with an x plus 2 in the denominator. And I am left with 2x plus 3 over x minus 1. Remember too, when you're dividing, that dividing is to multiply by the reciprocal. So if the problem had a division symbol in between it, okay, you would need to rewrite that by flipping the second fraction, and then it would be multiplication. If you're very, very, very uncomfortable factoring and you feel like this is where the wheels would fall off, then what you do is you save this problem to last. Okay, so when you encounter it, you skip it. You know it's going to have factoring. You're not leaving it blank because you will get partial credit, okay, for pieces of it that you can get factored correctly. So you're not leaving it blank. But you also are not going to let this problem take up half of your allotted work time when you know you can move through another problem faster. There's also a variation on this where you will see the work done out and you will be asked in what step is the error and what is the error. And so just those will be multiple choice questions where you will see the work done out. So this is your 23-minute review. Hopefully this helps and you will be ready to take your Unit 7 quiz.